Man, I just raked up my grass the other day. Perhaps I was getting ahead of myself. There's my project for the summer. Rehabilitate the little cabana. When we moved into this place, it used to have a, well, it was inoperative by the time we moved in, long since inoperative, a hot tub that was really nothing more than a house, mouse hotel. Hochin it was, Sandy. Sandy and Joel get that. Okay boys, we're finally out in the car. I've got the scope actually hooked up, just the hand tech. I've got the ignition actually on at the moment. It's in the run position. Maybe you can hear the fan. You can maybe see the fan speed indicator there, last calibrated on the 3rd of December 67. I'm sure that's just a random date. Anyway, I've got the scope here, and what I've got is back probed on the module. The connector is on the back side of the module here. All the plastic is removed so I could get the access to the connector there. And what we're going to check is the temp control actuator here. So my channels 1 and 2 are on both sides of the motor, and channel 3. Channel 1 and 2 here on the scope, boys, by the way, are yellow and blue respectively. Channel 3 is the purple trace, and it is actually coming off of the potentiometer pickup here. So we're sensing the position via channel 3, the purple trace there, right? So what I actually have is that I'm going to toggle it from the full cold to the full hot position, and you'll see the changes. So that's full hot now, boys. You see the 12 volts being applied to the one side of the actuator. It's reached the max position, its target position. The power's been removed from that side of the motor. You saw no change in the blue trace there, because that's the other side of the motor in order to toggle it in the other direction. And you can see we actually have 4.5 volts coming from the potentiometer. That's the measurement I've got selected on the scope. And from the manual, I've just written it by hand, boys. You're going to have to take my word. Max cool is 0.5 volts, and the max hot, which is where we're actually now, should be 4.5 volts. There's a plus or minus tolerance in the manual, but I forget what that actually is. So there's what we actually have. So we are, in fact, in max cold, max hot. Let me go back to the other direction. So if our thinking is right with respect to reading the schematic, you'll see the blue trace jump up to 12 volts. As 12 volts is applied to that side of the actuator to retract it, and the feed coming from the potentiometer should go down. The max cool position, max cold, is half a volt. So let's see what happens. I'll go to the max cold position, and that's exactly what happened. The blue trace jumped up to 12 volts until it reached its target's position, which is in fact the full cold position at the moment. And there you can see we have just over half a volt, right? I was puzzled by the serial data line, the communications line there, that was only a single line, not a CAN bus, but a serial bus communications on pin 13 there from the module that communicates between the HVAC module and the body control module there. Also, that's the display module, which is the module actually up there. Can you see that there, boys? It's saying it's 0 degrees. There's the temperature on the wall there, around 0 degrees. So yeah, that's the module there, item 27 on the drawing, by the way. So I'm going to actually back probe that on pin 13, and we'll take a look and see what the scope actually shows us with respect to that serial bus, because I'm interested. However, as I've said many times before, boys, the SX4 factory manual, the Suzuki manual itself, rarely lets us down. And sure enough, there it shows us, pin 13. G20 is the connector, pin 13. Gives us a serial communication line trace, reference waveform. And it looks very much like the K line. You'll notice that the Y scale, the voltage per division, is actually 5 volts per division. So that's between 12 volts and ground. It is not a CAN bus communication system. There is an independent bus that communicates from the HVAC module to the rest of the car. Quite interesting indeed. I guess the translation is probably done when the rest of this information is shared over the CAN bus. There must be a translator of sorts in the body control module. I assume that's just a guess, not much more than that. So give me a minute to pin the connector there, boys, and we'll take a look and see what it actually see what it shows. Sure enough, there is data being exchanged on the line there between 12 volts and ground. I think we can actually get it a wee bit better than the factory recommendation is actually concerned, that we go a wee bit quicker on the time base. We can get a wee bit wider pulses. Yeah, there you go. That looks pretty good to me. 1 millisecond per division on the time base there, and it's only chatting occasionally. Actually, that might not be accurate. This scope is only refreshing at a certain rate. This is a super budget scope, guys, as you can imagine. Let me get in front of the window there and try and cut in the glare a bit. There, it's a bit bare, so you can see the serial bus communication as per the schematic there, and as we discussed yesterday. So that's pretty interesting. I had no idea. I assumed that the communication between the HVAC module and the rest of the modules in the car would have been CAN bus. It is not. That's the HVAC module chatting with the rest of the modules in the car via the body control module. Now, this is disappointing. I'm sorry about the glare here, boys. It's absolutely horrendous, but I'm in reasonable sunlight outside my garage now for a reason. A fail on the VPECker's part. Shame on you. The PIDs for the HVAC system, the AC system, automatic AC system, the one was probably the most single important parameter in the entire system. Desired temperature, selected temperature, target temperature, temp select, whatever you want to call it. Can you imagine that it's incapable of reading that value? As you can see, the value there is only asterisks, which actually blows my demonstration for a couple of things right out of the water that I wanted to show you. However, I did want to show you that I've got a target temperature of about 20 degrees actually selected now, and you can see the cabin is in fact it's at 22 at the moment, so a wee bit hotter than what I've got selected, but that would trend, you can see it's actually trending down. The little ball there actually shows you the trend. So it's actually trending down at the moment. Given a long enough period of time, we would attain and maintain the target temperature. Sorry about the focus. Come on. I've actually got on there as well the sun load sensor there, boys. Sorry about the quality of the, and what you're actually looking at there is, if you're interested in the units, watts per meter squared, and the trace is actually just pretty much a function of the cloud cover that's going overhead at the moment. So let me just cover the sensor. By the way, that's the cabin temp sensor behind the grill there, boys. As I said, the little aspirator is behind there, putting that under a very mild vacuum. That's why this tends to actually get quite dusty, in case you were wondering why. The sun load sensor is actually up here, boys. So all I'm gonna do is actually cover it. Relatively opaque, this pepper. There's the sun load sensor, so you should be able to clearly see it's open and it's clear at the moment, and now I've got it covered. There's the instantaneous value right there. And again covered. So that's a quick and dirty check you can do of the sun load sensor, right? It's uncovered now, should jump back up. And there you can see there. And of course that would be a function of just how strong the light is actually on it. Again, sorry about the quality of the video here, boys. I realize it's mostly out of focus and the glare is horrendous. One thing I didn't include, boys, and I should have, because it would have been quite practical. When it comes to the sensors, if you have any doubt about the sensors that are in, well, really any part of the car when it comes to any of the thermistors, but especially the climate control system. Here's the cabin temp sensor. You can see it shown there. You can see the tube that goes off to the aspirator that I spoke of earlier. There's the sensor itself. Of course, it's a thermistor element. So it gives you specs in the manual for how to actually test it. Well, that's fine, but you can actually go the other way as well. So with that value, 2.2 kilo ohms at 25 degrees, 77 Fahrenheit, if that's the units you prefer. You could also get your decade box, actually dial that up, right? So 2.2 kilo ohms, and actually wire this into the chassis side of the car. And of course, your system, your scan tool should read 77 degrees or 25 degrees Celsius. So that makes some sense. And you can also do the same, of course, with the, and I have done so. There's a video elsewhere on the channel, guys. You can go find it if you're interested, where you can actually go to the engine coolant temp sensor. It's actually mounted just near the head and the block here on the left hand side of the car, under hood, of course. And you can actually, here's the chart that actually gives you in the manual, so you could pick a value, whatever. You can see here it's actually 2.2K again at 20 degrees. So you could again dial up whatever value you want. You can cross check what your scan tool is actually reading if any of the sensors in the system are actually in question. So it was getting pretty nippy outside, and I brought all my gear back in, so I had called that day by the time this occurred to me. So here's my channel page, 399 subscribers. That's amazing for me. Thank you very much to anybody who's taken the time to subscribe. And all I can say is, don't you have something better to do with your time? That's it, boys. My coffee's ready. Cheers.